Hello, let's start section 2.8. 2.8 is distance and midpoint formula, and also we talk a little bit about circle, but not that much because circle is coming back in the conic chapter, and we study circle in a conic chapter. But the distance and midpoint formula, definitely we discuss it, correct? To start with distance, what is distance? You want to find the distance between 2 points in a line segment, correct? If you have a line segment, you want to find the distance between 2 points. Let me draw here a little bit good graph, because in this graph, I will explain a lot of things for you, correct? And I'll draw the x-axis here, correct? This is your x-axis, this is your y-axis. Let's draw a line that passes, for example, through, is it okay if it passes through the center? Yeah, let's draw this line. I will draw another line here, which passes here from the center. Any line, it doesn't matter if it passes from the center or not. But this one I choose to, in your book, they choose also to pass this from the center. This is a line. Now, let's pick 2 points on this line, correct? Even let's use this point, correct? Let's close it here, stop, and let's choose another point here. But if I now want to erase, everything will be erased. Yes, I know. Now I have to draw my line again here from this point only to this point. Let's say from here to here. Let's draw, for example, this is a line segment, correct? Line segment, piece of line. Our goal is to find this distance from here to here. How much is this distance, correct? To do that, let's name this point, for example, x1. The coordinates of x will be x1, and for this point, this one will be x2, right? The coordinates of this point will be x2. Now, we did this before when I proved the slope formula for you. I asked you a few questions, then I answered myself some distances that I need. Let me draw this triangle now for you. If I draw this, how much is this blue distance? We already discussed this. This distance is x2 minus x1, correct? And if I draw from here to that point another vertical line, this distance is y2 minus y1. Now, in school, I'm sure, starting grade 7 or 8, you saw this formula, c squared equals a squared plus b squared. Pythagorean theorem, correct? If you have a right triangle, this side, if you square it, it's equal to if you square the two legs, correct? And add them. We call this one Pythagorean theorem, a very, very famous theorem that everyone knows it, correct? Now, look at my shape and look at this theorem. They are the same, correct? Then if I want to find this side D, my D square actually equals this leg square, which is x2 minus x1 square, plus this leg square, which is y2 minus y1 squared, correct? Now, I don't need D squared. My goal is to find D, the distance. If you take the square root from both sides, then D equals plus minus square root of x2 minus x1 plus square plus y2 minus y1 square, correct? Now, in your book, they don't show this negative sign. The reason is distance cannot be negative. That's why we just choose the positive value of D, which is a distance. We call this last expression or equation the formula to find the distance between 2 points if they give me the coordinates of those 2 points, correct? If I have the coordinates of 2 points to end point in a line, I can find the distance between those 2 points, correct? Let's do examples now. Example number 1. Find the distance between points -1 and 4, and the second point is 3 and -2. 3 and -2. They're asking you to find the distance between these 2 points. First thing first, formula. D equals a square root of x2 minus x1 squared plus y2 minus y1 squared, correct? That's the square root of it. Now, let's plug in the values. D equals a square root of x2. This is your x2, right? It means 3. Minus x1, minus -1 squared plus y2, your y2 is -2, minus y1, which is 4, and squared. Simplify. D equals the square root of double negative becomes positive. 3 plus 1 gives you 4, and 4 square is 16. Plus -2, -4, -6, -6 squared gives you positive 36. And now, from here, D equals a square root of 62. Am I right? 6 plus 6 is 12, 4, 5, 52. That's it. That's the distance between those 2 points, correct? If they give you 2 points on the line, just plug in this formula, you have the distance. Next topic to discuss is midpoint, the midpoint formula. For example, again, xy, and I have like this line, correct? Coordinates are x1, here x2, and here of course y1, and here of course what? y2. I want to find the midpoint between these 2 points. The midpoint between these 2 points, if I show, in some books we show as a MD or DM midpoint, but in your book they only give you two formulas. To find the midpoint, your midpoint will be, the coordinates of x will be x1 plus x2 over 2. It's like finding the average, right? And the coordinates of y will be y1 plus y2 over what? Over 2. We call this one the midpoint formula. Correct? Now, if someone gives me the coordinates of 2 points and asks me, find the midpoint, it's easy to find the midpoint, correct? Let's do an example. Example number 1, find the midpoint of the line segment with the endpoints. The endpoints are given as a 1, -6, and the second point is -8, -4. They're asking you to find the midpoint, correct? Again, x1, y1, x2, y2. To find the coordinates, the midpoint at x, let's name it mx, correct? Or m of x. This is the midpoint for x. The midpoint for x is x1 plus x2, right? It means 1 plus -8 over what? 2. And the midpoint for y coordinates is y1 plus y2, which is -6 plus -4 over 2. Simplify, it gives you the coordinates of midpoint, correct? 1 minus 8 gives you 7 over 2. Correct? This is your midpoint at x. And here, -6, -4, -10, -10 over 2, right? Which gives you -5. That means your midpoint at y is the coordinates -5. What is the coordinates in general for the midpoint? 7 over 2, comma what? -5. I went a little bit fast in this lecture because nothing is difficult in this lecture. Only two formulas that you have to remember. Even now, because you learn how to find the distance between 2 points, it's easy to talk about circle formula, correct? Let's now talk about what? About circle. Let me draw here a circle. Hopefully, if I can draw that. Do I have a circle here? Shapes. I don't have circle. Very bad. Okay, I'll use my hand. Don't laugh on my circle. I know I cannot draw a good circle here. I'm trying. If I was on the whiteboard, it was much faster, maybe much better. Think it's a circle, right? I know it's not a circle, but think it's a circle. If I draw a line from here, from the center to any part on a circle, we call this distance the radius, correct? Everyone knows what is the radius because all the points on a circle, they have the same distance from a point that we name it what? Center, correct? Let's put here C. Now, if I name the coordinates of this point, for example, x and y, and if I name the coordinates of the center, h and k, correct? Let's name it. In your book, they choose h and k. In most of the books, they choose it h and k. If I ask you to find the distance between h and k and xy, you should be able now even to prove the formula for the circle, because it's the same as distance formula. You can write r squared equals x2 minus x1, right? It means x minus h. Your x1 is now h square plus y2, which is y minus y1, k squared. And you take the square root from both sides, you end up with r. Even you don't need to do that. But in some cases, we calculate r equals x minus h, square root of x minus h squared plus y minus k squared. Both of these formulas, we call it the formula for the circle in standard form. Circle formula, standard form. Correct? Now, if they are asking you to write the equation for the circle, it's really easy to write the equation for the circle. Of course, to write the equation for the circle, you need the point on the circle. Correct? If they don't give you those points, you cannot write the equation for the circle. Correct? Let's do an example. Write the standard form of the equation of the circle with the center negative 2, 3. Example, write the equation. The center is given as a negative 2, 3 and radius 4. Your radius is 4. Write the equation of the circle in a standard form. Correct? Usually we use the first formula, this one, a lot to write the equation of the circle, not with the radical. If you want to find the radius, how much is the radius, use this one. But if you want to write the equation for the circle, always use this one. Correct? Now, when you are talking about center negative 2 and 3, let's know negative 2 is your h and 3 is your k. H and k is given to you. Is this difficult to write the equation for the circle? No, just plug in the formula. My formula is r squared equals x minus h squared plus y minus k squared. Correct? Even I like it to move this equal sign and r squared on the right side, equal r squared. I like it this way. Okay, this is the equation of the circle, the formula. Now I know the value of h and k. Then x minus h minus, how much is your h? Negative 2. Correct? Square plus y minus k. How much is k? 3. Squared equals r squared. How much is r? 4. 4 squared. Double negative becomes positive. Then you can write x plus 2 squared plus y minus 3 squared equals 16. The equation of the circle in a standard form, which the center is at negative 2, 3, and the radius is what? 4. Now, in the formula, I don't want to make it more for you, but this is a simple form. Let me explain to you. If the center of the circle is at 0, 0, it means the center of your circle is here at the origin, like this, 0, 0. That's your center, correct? Then what will be the formula, the easiest formula to use to write the equation of the line? Look, your general formula is x minus h squared plus y minus k squared equals r squared. Your h and k is 0. And if I plug in here 0, it gives me x minus 0 squared plus y minus 0 squared equals r squared. It means I'll end up with x squared plus y squared equals r squared, the simple form of the equation of a circle if the center is at the center of coordinate system. It means your h and k is 0, 0. Correct? This is all about 2.8. And this is the last lecture for chapter 2. Um, Again, after you finish your test, or even before you finish your test, um, we will start soon with chapter 3, which is to talk a little bit about your chapter 3 is polynomial and rational functions. They're really, really interesting. Um, we in this chapter try to try to talk about these functions. Some rules um, are involved, and this is actually chapter 3 is one of the interesting chapters in your book. Here we are done with chapter 2. I'll stop the lecture and see you all in chapter 3.